So this is in 2 chunks. Genius. Oh, Fletcher, I missed all your comments today. They're so good. Okay. Now, next thing. Let's put this. Okay, who we missing? We're just missing Cole. Everyone else back in there in Cyberland? Good. Okay. And then I want to pull up one more thing. Say it again. Yeah.
If I have something like that that I want to install, am I looking for am I looking for something simple or am I looking for sound stuff or I can't get like a good but I feel like there's a different
Like you want to bring in an audio file to SC?
let's say I want to let's say I want to write a piece that I know I can buy. Am I looking for a sound stuff of a violin or am I looking for a simple violin that I can somehow turn into?
Well, I guess the question is, why do you want a violin? Well, why not just get a violin player to play it? Well, this is an interesting question, actually. Okay, so SuperCollider does a lot of things really cool. SuperCollider does not recreate instruments very well. That's not what it's great at. Violins do a lot of really cool things. Violins do not recreate crazy, random, aleatoric soundscapes that SuperCollider can do very well. Well, then though, still not really. I think the thing is here that what I like to think about is like, what is SuperCollider and what is it as an instrument and tool that it does well, and allow that to be the extension of my voice through that way. If I'm in composer mode, like just straight composer mode, and I got a violin in my head, then I want to go get a violin. So I can either get a violin player or I can go into a DAW and use a violin sample library or some sort of high-end plugin that does that, in my opinion. But I don't think SuperCollider is the best way to try and do that. We can emulate. I mean, there's a whole fucking research area in synthesis in modeling called physical modeling. And the goal is how do you recreate through synthesis physical phenomenon of the world? But it's all just math and physics. And the people who do it aren't typically that creative or interesting. They just aren't. They just aren't. So not to push back, Bearcat, but what I think you should think about is to say, what tools do I have? Either, if this is what I have in my head, let me go do that thing. But, or if you're constrained by the tools you have, then you have to say, what are the tools I have and what do they do well?
So what is the sound font? Versus the sense of what are the type of
A sound thought?
sound font versus the sense of what are the beats and things like that, and how are they-
And what is a sound thought? Sound font. I have no idea what that is. Yeah, let's view it. Yeah, let's see what the Google says. Oh, yeah, sure. So some samplers use sound fonts. Okay, yeah, no, I have come across this before. So some samplers use a format. So it's a format. It's a way of essentially collecting data so that it's all formalized with each other. Yeah. Yeah. Okay. Where am I at? Ah, yeah. I lied. I'm actually going to take 2 more minutes. I'm going to go to the sound studio. I'll be right back.
Sorry.
Let's work through some of this stuff right here. Okay. Yeah, cool. So let's say we set up some sort of basic simp def of some sort. Simp def, we're going to call it things. Not going to be anything abstract or crazy. Arg is going to be stuff we're really used to. Freak amp equals 60 note equals 60 amp equals number 6 bars envelope signal. Huh? No, I don't think so. I don't think so, but we'll find out. Just dot AR density. We'll do something like 2 dot lag. And I'm going to do 0 up. We haven't talked about this yet, so we'll look at it in a second. Lag is a cool method that when we apply it to a unit generator, wraps the receiver in a lag UGen, smoothing its output by T1 seconds lag time. If a second argument is given, it wraps it in a lag UD, up, down. So we can say whenever dust remember, was just like random impulses. It's going to go up to 0 or up to 1. It's not going to lag at all. And then we're going to have it take like 0.3 seconds to lag down. And we'll hear the effect of that in a second here on our sine oscillator. Sine os. There they are, frequency. So we're going to freq will be notes.midi CPS. Will be amp dot. Is that right? Man, so I really did not sleep well last night, everyone, and I'm so sorry about that. Walking out. Doing great. TV amp. So I think that's it. Okay. Out.ar. We'll go 0. We'll sensei. Oh, wait. Oh, that's why. TV. And then I forgot to sig is equal to sig times. Great. So the next thing I'm going to do is I'm going to add an out argument. We're initially going to set to 0. Great. And now let's talk about some signal processing parameters that we can do. We're also going to create actually one more synth here that'll be kind of similar, except we'll call it white things. White noise. Cool. We have those two now. Okay, so what I'd like to talk about is buses a little bit, and how we can take audio from one thing and send it to another thing, essentially. So as we mentioned, a bus, and I'm not set up to draw here. Give me one more second. That thing. Yeah, right? It's not a bad one. It's not bad. Then we'll do full screen, and then we'll go ink to go, whiteboard. Oh, come on. Look at that. Whiteboard. So, a bus, as we mentioned the other day, can collect audio from multiple places. It combines it together and it can bus it somewhere else. Okay, makes sense. So in SuperCollider, we've been using this out.ar unit generator in order to send audio to our main speaker outputs. However, we can actually also use out.ar to send audio to other unit or to other synth apps, which can be really handy when we're trying to do mixing or complex processing of say that we go on. So audio. Have options that come up. So I'm going to open up the representation of an audio or control bus on a server. Encapsulates all of the OSC messages. So notice, remember I use OSC to communicate between SuperCollider and processing. SuperCollider uses OSC to do all of its communication between the interpreter and the sound end. And so OSC is baked into SuperCollider at a very fundamental level. Open sound control, but think of it really as just a data communication protocol. It doesn't have to be sound-based information. Essentially, a bus allows us to create some sort of avenue to send data on, whether that's control data or whether that's audio data. So if I wanted to create a new bus, I could say audio bus. Notice now I've created a new bus. Great. So let's say I create another synth of some sort. Audio bus in, just for the time being. All right. In, we'll initially set to 0. Variable signal. So to get audio into something, we use in.ar. Again, we're going to open up, since it's the first time we're using it, we'll open up the help file in.ar, in.kr, read signals from an audio or control buses, respectively. In.ar can access audio signals that were generated in the current calculated cycle by the synth nodes. We're going to ignore what that means for the time being. And then if we look, it's got examples of how to use it. Cool. So I'm going to say signal with in.ar comes in on in, whatever that happens to be, out.ar bus. We will send this to 0. We'll just send out 6. Yeah. Who can help Bearcat? Yeah. Yeah. So it's again, just is the signal audio or not? If it's audio, do it at audio rate. If it's control or not audio, do it at control. Does that make sense? I know that's so simple when I say it that way, and I sound like an asshole, but okay. Cool. Cool. Okay. So oh, sorry. Okay. So we're going to launch synth audio bus in. And then what I'm going to do is I'm going to pull up my show node tree. Notice now we are playing this synth audio bus in. And I'll also pull up a meter just so we can see what we have going on there. The other thing though I'm going to do is I'm going to actually, I stopped it. I'm going to add in an argument in. We're going to pass in audio bus dot index. I'm going to execute this real quick. Audio bus dot index. Notice it tells me what is the number index. And so remember when I created this audio bus. It was bus of type audio, and it told me the number that it's the channel number that it's using. So by assigning it to a variable, essentially, we don't have to remember the number. We can just remember a human readable variable name and pass reference to that name around everywhere. So we're essentially naming our buses. Maybe we should do this one other way first, and instead we'll go synth. Let's do this. Amplitude.kr. Amplitude.kr tracks the peak amplitude of a signal. It's essentially an amplitude follower. We can use it to drive a lot of things. It's a basic machine listening algorithm. And it's one that becomes really useful really quick. But if I pass in amplitude.kr and I pass in sig, and then we pull it, notice we have an amplitude of 0. Okay, now I'm going to take this line here, that our sig line, and just to show that this does work, we're going to replace it with sinos.ar. Doesn't matter what we do here, but we'll also multiply it again by sinos.ar with a frequency of 0.5. And we'll go to our range 0, 1. Notice here, my amplitude is between 0 and 1, depending on how this amplitude modulation sign off is multiplying. So we can see that amplitude thing is working. So this will essentially serve as just a debugging ability for us right now. Too many programs managed at once. Whoa. Yeah. You're seeing 9.18118 e to the negative 0.7. What does that mean? Means it's not 9. 9 times e to the negative 0.7 or whatever is actually 0.00345679. Just an exponent saying it's very close to 0, but not quite 0 internally in the computer. Welcome. Thank you for asking about that. That gets a lot of people in trouble at first, and it's always something good to go over. So we now know we can verify that amplitude is working. And right now, we can see amplitude is 0. I will take my white pings here, play it, yeah, out, and we're going to send it to, so we'll do it, we're going to do it by brute force first. In, we'll go on 6, out, we'll go on 6. So, what's happening now? White pings is being routed into our audio bus here. Oh, I'm lying entirely to all of you. No one called me out on it. White pings has to go out, otherwise it doesn't do it. Now let's try this again. And we see the amplitude thing working now. So verifying that it actually is doing what it was supposed to be doing. So again, we're telling audio bus in to run. And we're saying accept audio in on channel 6. And then on white ping, we're saying run and send your audio out on channel 6. Great. This isn't groundbreaking, is it? We haven't done anything crazy complex yet, have we?
Wait, so is that synth def, is this not def, is the synth def in line 47 also playing sound, or is it just telling us the amplitude? Or I guess it'd be in 62 is where the synth is actually playing. In line 62, is that also playing sound simultaneously? And if it isn't, why not?
It is. It's taking the audio in and it's sending it out 0.
Okay, so would 63 also be playing?
63 is playing out of 6. So if I play this by itself, that's the great next experiment. Notice we have nothing being played. We can see that it's being played, but it's being sent out 6. And if I pulled up show scope, we see there's no audio going out my first 2 tracks. However, if I move the track that we're focused on to 6, we now see that white noise. This is internal. So this is an internal audio bus.
So what exactly is preventing it? So if you were to scroll up to the synth def for white pings, can you explain in the synth def what's preventing it from actually outputting sound?
It is outputting sound. It's outputting sound to channel 6,
Okay.
which is what we told it to do in line 63. If we ran it without telling it where to send sound, it'll send it to 0.
Okay, great. And since we only have what 0 and 1 to work with in our system, it has to either be 0 or 1 for it to output.
To the speakers, yes.
The speakers, yes. And so when we are putting, and so in line 62, or I guess when we're plugging that into the bus, we're taking the audio from channel 6 and putting it out on channel 0.
Yeah, that's what we're doing in this audio bus in synth def, is we're saying grab audio from somewhere
Mhm.
and then send it out to 0.
Okay, that makes a lot of sense actually.
Why are we doing it in the first place? Why do we want it? Why do we use buses? Huh? Yeah, to move sound around. Because it does exist. It exists internally. You know, like a big mixing board? Yeah. So 64 channels, 32 channels, 8 channels, 197 billion channels. It doesn't matter. Okay. Each channel by default goes to what? At the bottom of that whole channel strip, where does it get routed to? The master bus. 0 and 1, depending if it's just a stereo channel track. Typically in the middle of your channel strip, you'll have an aux section. What is that aux section? It sends audio. If you engage them, it buses that audio to an auxiliary channel. You could use an auxiliary channel for outboard signal processing. You could use an auxiliary channel to create a submix that you would then later send to the master bus mix. You could use that auxiliary channel to create a headphone mix that you sent to musicians in the main recording room that never went to main bus. You could use that auxiliary channel to split audio and send a dry signal to the main bus and send an affected signal to some processors that then get mixed back in. We use buses for all kinds of creative purposes. And we just need to know about it.
I guess my confusion
Yeah. Mm-mm. It's just a demonstration. It's just to say, hey, look, we can take sound from one synth and send it to another synth. Bus and send. Oh, like on a mixing board, or yeah, like in Ableton. Yeah. Thank you. Sorry. I was like, send actually has some very specific reasons in Supercard. Yeah. Yeah. And why might you want that? There's two reasons for that. One is processing overhead, and two, yeah. Even if every instance of the reverb was the same over multiple tracks, by having this multiple instances of it, reverb kind of serves to glue sound together as though it's occurring in a similar space. So when you mix a bunch of sounds together and then send them through a single reverb, it creates a sense of cohesion in audio, which is the second reason why you typically do that. It can save on your CPU. Same thing. And we may want to do the same thing, where we may have two different sounds going on, such as pings and white pings. Gosh, what horrible names. And we'll get to that in a second. Some processing of what we might want to do with those. Okay, there's one other infuriating detail that you're all going to have to remember here, and that's going to be order of operation. So how do I add notes in here so this makes sense? Send. Okay, so you can use numbered buses. Totally fine. You're allowed to just use numbers. I think by default, SuperCollider starts with 128 buses, channels, or something like that. It starts with a fairly sizable number. And so if you want to keep track of the numbers yourself, you are welcome to do that. What is the potential downfall of using straight integer numbers and tracking them yourself? You can lose track. Well, yes and no, but complexity could get you in trouble. If you start getting a whole bunch of buses, you might get confused about which number you're using for what. So by assigning them to an environment variable, we can use a name that makes sense to us and use that in place of it. So essentially just using code, basic coding principles, it makes it a little bit easier. So notice audio bus, we created it, bummer. And initially it was bus number 4. Why do you think it picked 4 to start with? What's 0 and 1? Left and right. What's 2 and 3? Yeah. 2 and 3 is input left and right. So again, if we look here, so it automatically is pulling in sound from my microphone, my 2-channel microphone on 2 and 3. So 4 was the first available bus for it to allocate and assign. And so that's why it picked number 4. I accidentally reallocated it, and so then it put it on number 5. That's fine, doesn't matter. And we said this is just a single channel bus. We could make it a stereo bus. Now notice it's on channel 6, and it's using 2 channels. We could make this a 32 channel bus. Doesn't matter, okay? One thing you should do is when you're done with a bus is you should free it. Audio bus, free. Because then they could be used by something else, but whatever, I didn't do that. So. Yeah. 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 Okay, so we've got this audio bus, and let's say we want to use an audio bus instead of a number. Name. We allocate it. And then we say audio bus dot index. Audio bus dot index. An index is just the number that it's assigned to. It's just a shorthand. Cool. How exciting. Okay. So now we're sending 2 things, white pings and pings, to audio bus. Now, what do you think? What is odd about this? What is odd about the way that I'm writing this right now? Seems out of order. Yeah. So the thing I'm doing is I'm putting the bottom first, and then I'm passing in a new synth. And what SuperCollider does, when it creates this ultimate synth graph it's creating, it takes the new synths and it puts them on top. So notice when I create pings, that went on top of our synth group. So it takes the last in and it puts it on top of our stack. So for audio flow purposes, you need to work from top to bottom. That means you're starting things from in backwards order. It's very confusing. No one's going to like that. But just to prove it to you, this should not work. So both of them are playing again. But what's happening is that white pings is putting its audio information on the bus one cycle after the other synth has already read it. That's exactly it, Bearcat. Shit, that's the first time you got something so nice. Yes. Does everyone else, does that make sense for everyone else, kind of? Say it again. You said it so eloquently. So sage. It's just perfect. Yeah, you would. Okay. So, the following does not work. You must take the conduit and do it. As Bearcat so eloquently put it. or you must tell SC what to do explicitly. So if we actually created this one first, we can still add this one. Afterwards, notice here we've got an argument in here that says add action. One of the following: add the head, add to the head group, add the tail, add after, add before. So let's say we've got a reference to our whatever. So we don't need to worry about target. But add action, instead of add the head, I'm going to say add to. Oh, that's sort of. Oh, but I'm muted here. So now we told it explicitly in this instance, put yourself at the bottom of the order of operations and just insert yourself. SuperCollider has to go through a couple of additional hoops in order to make that work. It's happy to do that if you wanted to do that, but that's why it's not by default and has to do one extra thing internally to make that happen.
I've got a quick question. Can you explain what exactly audiobest.index, what is that doing for us?
Yeah. So audio bus, where did our audio bus go? Ah. To explicitly, whoa. Reference the channel number, use the dot index method. So audio bus dot index just passes the number that it's on. So this explicitly passes the integer 8 instead of us writing an 8.
Okay, so dot index, it just kind of takes the number from it.
Yeah, it says what's the starting number of the audio bus.
Okay.
That's all it's doing. Yeah, so you could actually, like, let's say we wanted to do this in stereo, which we actually set up to do anyway. Saying things. We'll create a stereo bus. And here, audio stereo bus in. Notice number of channels. I'm going to say I want 2 channels. And now audio stereo bus is actually what we're going to call it. Audio stereo bus. So we'll play it and then audio stereo bus. Oh. Oh. So then if we're developing, Oh, that didn't actually, hold on. Go backwards. In audio stereo bus, that's what it is. So now pulling in a stereo bus, because we told it stereo. We could also add another argument that was something like number of channels. And it'd be audio stereo bus dot, I think it's number of channels. So now we just tell it how many channels to add in. Yeah, you could do that too. Yeah. Cool. Okay. So this is a very simple example. We're going to come back to buses more later. But what this allows us to do is to start create complex signal processing chains that if we wanted to, we can hot swap things. Because the final thing to show is something like well, at any rate, we'll get to it more, but we will get back to buses. They're an important thing to know. Okay. So come on, Michael. Signal processing examples. Let's just call it that. Hard in, moving in. Sig. So we'll get to some of these other methods a little bit later. This is a good one though. Oh, yeah, we'll get to some other things later that are really interesting as well. Shoot. Okay. Yeah. Okay. So what is a delay, Eugen? What is a delay?
Just takes a signal and pushes it back.
Yeah.
Like a specified amount of time.
So if we have a signal, it grabs that signal and it delays it by some amount of time before sending it back to our output. That's a speaker. And the most simple of that is a comb and no, is a delay and simple delay line with no interpolation. Simple delay line, no interpolation. We're going to talk about that later. Yeah. So let's see what it sounds like. We're going to pretend that we've already talked about inputs. And is it worth it? Yeah, we got something. Let's see if we can't blow up some speakers. What? love when people don't know how to use. You know, the worst part about having the sound class be online is that I'd like to spend 2 weeks on how to wrap cables. So, O is going to be equal to server, S dot options, O dot in device equal to, what do we call this thing? Big, studio. Great. So now my input device, and my output. Oh, we are not sending audio to Zoom. Shoot. Oh, that's not good. Why didn't anyone tell me?
I didn't know that anything had started.
Yeah, I thought it was chilling.
Oh, man.
I just thought you were messing around with some things.
Yeah, same.
Cool. Well, there's a whole bunch of code here. You guys missed it all. Bah. Okay. Well, that sucks.
We heard the things that came before. We heard when we were doing the bus processing. We heard all of
Oh, you
that.
saw all that?
Yeah.
Well, we heard it
Okay.
because it
Okay.
was coming out.
Well, we'll see what happens.
It was coming out of the speakers, so it was being caught up by your microphone. So it was
You didn't
heard
see any of the code.
in some regard.
Bummer. Okay. Well, it'll exist on the GitHub. Okay. We're going to short circuit here. So notice now, if I turn up, we should see the input coming in. I'm going to turn my main output down. Okay, cool. So now we have sound going on. So a delay and no interpolation. We're going to pass an in sig, max delay time 1 second, delay time 1 second. We'll play it. Whoa.
That's just iSig.
Okay.
Okay,
Hello.
hello.
Okay, so all it does is it takes my sound, as I mentioned,
Takes my sound, as I mentioned,
and it delays it by 1 second.
and it delays it by 1 second.
Good.
Good.
So
So,
cool thing is though, we can start to modulate this. So, okay, let's keep the example as is. Where is one foot? Max delay time is set to 4 seconds. And the delay time we'll set to something like delay t equal to 1. Sensitive. Are you working?
are you-
So now go a dot set delay t. Okay, so let's see what this sounds like if we go from
okay, so let's see what this
a dot
sounds
set
like.
delay t from 1 second, we'll go to 3 seconds, we'll execute it, and then
A
it does
Oh,
set delay T. From 1
drop.
second, we'll go to 3 seconds. We'll execute it, and then we'll see if it changes at all. And there should be just a drop.
Didn't do anything.
Didn't do anything.
So let's be smarter about it then. And add a is equal to synth. Looks like it. It may not do anything quite like I'm hoping it to. I don't use this UGen in this way. So again,
Again,
again. There's a 1, 2, 3, 4,
There's a 1,
5.
2,
Yeah, it's doing it.
4, 5.
And I guess the thing to check would be if we go 0.3, and so we're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
10, 11,
16,
16,
17.
16.
So you get it changes the thing up from 10 to 10. Okay, cool. Yeah. So notice when I reboot here, it shows all of my audio interfaces. And so I'm just using a named audio interface. And I'm saying that I want to explicitly use that as the end device, regardless of what my system is using. Because my system right now is hopefully using my Mac, built-in Mac microphone for Zoom. And so my internal audio routing in my head is all messed up. Remember that lag Eugen I used a few minutes ago on the dust.ar for the signal noise things? So here's something cool we can do. That'll create a nice little effect of some sort. Delay time. Lag to create. I can go delay time dot lag over 4 seconds. 1, 2,
1,
3,
2,
4,
3,
5, 6,
3,
7,
4,
8,
5,
9,
6,
10,
7,
11,
8,
12.
9, 10, 11, 12.
1, 2, 3, 4,
1,
5,
4, 5.
6. Oh, the lag doesn't work on this instance. That's interesting. Should have done it. Delay time T dot lag. Yeah, whatever. Okay. So at any rate, this delay stuff, horribly boring. The one that I find more interesting, well, okay, so let's say, as the last example, let's say we also wanted to have the real-time version of this. What could we do? So let's say we wanted both the original signal and the delayed signal. So I also wanted to complete this here.
Could you make 2 different signals and add them together?
Is that what you're going to say too? So there isn't a dry wet on this. So we have to do it explicitly. But that's exactly it. So we've got in sig and we've got sig. We could then say sig is actually equal to in sig plus sig. And then we should have both together.
And then we should have both
1.
together. 1.
That doesn't sound good.
It doesn't sound good.
Come on.
Come on.
Okay, hold on. Let me think this through. In sig, we're not replacing in sig, so sig is equal to mix. So we need
So we need to use mix. So we need to use mix. I always forget mix.
different
I always
different
forget
environments.
some different
So now we have my live
So
sound
now we have my live sound. So now we have my
and
live
we have the
sound.
delayed sound.
And we have the delayed sound. And we have the delayed sound.
Cool.
Cool. Cool. So let's say we wanted to have a wet dry mix. What would we need to do here? Let's say we wanted to have a wet dry mix like we typically would in a normal signal processing chain or element.
Don't you just have to change the mole? Or you could bus process them.
I know, he's quite loud. Wet dry ratio. 0.5. Yeah. What were you saying? Yes. So if it was a 1 fully wet, we would have 0 insig. So we could say wet dry insig insig times wet dry ratio times, come on, it would actually be 1 minus wet dry ratio. Yeah, so if it's 1, we're getting 0. If it's 0, we're getting 1. Likewise, sig would be equal to sig times wet dry ratio. Cool. I don't even know what that is. Yo. If I go A dot set wet dry ratio.
Da 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 da. Oh, come on.
I know.
I know, because you can't see shit. I know, because you can't see shit.
I spell it wrong here? Wet dry ratio.
Wet dry ratio 1. Wet dry ratio 1.
Oh, yeah.
Oh, yeah. Oh, yeah.
Wait.
Wait.
Why is that not doing it? Anybody
Why
catch
is
it?
that not doing it? Anybody catching it for me? Anybody catching it for me? Yo.
Mhm. 156. It's got to. I have to have done it wrong somehow. Yo.
Yo.
Oh, now it's working.
Oh, now it's working.
Not sure what that's about.
Not sure what that's about.
Now, it's just delay.
Now, it's
Now,
just delay.
it's live.
Now it's just live
Okay.
signal.
I just hadn't compiled it for some reason. Sorry. So that's how we could include a wet dry ratio. What happens if I multiply a signal by 0? Yeah. What happens if I multiply it by 1? You get the same thing. I haven't changed it. What happens if I multiply it by 0.5? You got half the signal. Yeah. Well, it's actually a little bit, it's quite a bit more than half as loud because it should be, you're gonna hate the next piece I do. Amp dB. Amp dB, but yeah, now it's actually half as loud. Because 0.5 amp dB equals what in decibels? -6, which is half the volume. Yeah. -6 is a fairly, oh, and actually, we don't want to do it that way. I'm doing it wrong. No, 0.5, fine. Yeah, it should be, if it's 0.5, we want it to actually be 0.707. Anyway, this is a rough wet dry mix. You get the math like this. You remember all your signal processing information? Yeah, cool. So, yeah. So if we want something that's all wet signal, if we multiply the wet signal by 1 and the dry signal by 0, we get all wet signal. If we want something that's all dry signal, we multiply the dry signal all by 1, the wet signal all by 0, it's all dry signal, right? So this just is an inverse relationship, saying if the ratio is 0.5, will be 0.5 on both. If it's 0.7, in say will be multiplied by what? What's 1 minus 0.7? Yeah. If it was 0.9, what would it say be multiplied by? Yeah. So we're essentially affecting that wet-dry ratio, making it wetter for them.
You've got two variables. One of which is the other variable.
So we're combining our dry signal, our microphone comes in with our effective wet signal right here. And all we're saying now is we want a wet-dry ratio that can affect the mix essentially between those two signals. You know, like on a reverb processor, it always has a wet-dry. What does wet-dry do? Yeah. So this is just literally, that's how they do that. This is an example of how someone would code that up in a GUI-based effects chain. Cool. We're done for today. No sketch next week. We're gonna jump headfirst into combs next week and filters, and then p-binds the second half of class. Nope. Nope. Nope.
Thanks for making Zoom an option, Michael. We'll see you next week.
Yeah, see you guys next week. What were you saying, Bearcat?
Yeah, thank you.